In this hyper-realistic photograph, we observe a terrifying, rotten mutant Omega Mart lemon fruit tree monster. This humanoid creature resembles a rotten lemon fruit with a human head, showcasing its fruit-like body, gooey texture, creepy expression, and sharp fingers in exquisite detail. Positioned on a wooden table within a spooky forest during golden hour, the creature is surrounded by twisted trees, gnarled roots, and a saltwater mountain lake. The vicinity features mountains adorned with tall green pine trees, snow, and ice. Alongside the saltwater lake and river teeming with colorful fish, coral, water vegetation, and enchanting mermaid goddesses, Japanese cherry trees with pink flowers, vibrant wildflowers, and tall green grass line the shoreline. To capture optimal image quality, state-of-the-art Technicolor technology will be used during daytime. The scene aims to portray a sunset at a mountain lake, featuring sun rays, caustics, and an artistic anamorphic lens flare. The visual style will be photorealistic with warm hues and green tones, incorporating realistic lighting techniques such as ray tracing, global illumination, and quantum wave tracing. The table will be adorned with vines and branches to enhance the atmosphere. Post-processing techniques, including denoising, adjustments, and color grading, will create an incredibly detailed and lifelike image with a hyper-maximalist and ornate feel. Advanced technologies, including deep learning neural networks and generative adversarial networks, will generate photorealistic 3D images of the forest and the creature, capturing intricate details. Realistic shadows, reflections, and caustics will be incorporated into the water using ray tracing, global illumination, and quantum wave tracing techniques, heightening the overall lighting and atmosphere. The image's tags will effectively convey the essence of a scary, rotten mutant Omega Mart lemon fruit tree monster, surrealism, nature, and art, showcasing the eerie forest setting and adding atmosphere and tension. To adapt humans to this environment inhabited by plant and tree monsters, various adaptations are needed. Genetic engineering can enhance human tolerance to potential toxins emitted by the fruit monsters and improve respiratory systems. Cybernetic implants can enhance vision and perception for navigating the treacherous forest terrain. Nanotechnology-based modifications can reinforce the human skeletal structure for increased durability. Surgical alterations can enable humans to breathe underwater through gill-like structures or advanced respiratory systems. Neurobiological modifications can enhance sensory abilities to perceive and interpret the forest's intricate details. Augmented muscular strength and agility are necessary to cope with the physical challenges posed by the environment. To implement these adaptations, a series of advanced medical procedures would be required. Genetic engineering techniques would be employed to modify specific genes responsible for toxin resistance and respiratory system improvement. This could involve gene editing tools such as CRISPR-Cas9 to introduce desirable gene variants or suppress genes associated with sensitivity to toxins. Cybernetic implants for enhanced vision and perception would involve sophisticated surgical procedures. Neural interfaces would be integrated with the visual cortex to seamlessly integrate augmented visual information. Microscopic cameras and sensors would be embedded to capture detailed visual data and transmit it to the neural interface. Nanotechnology-based modifications for reinforcing the human skeletal structure would utilize targeted delivery systems to introduce nanomaterials with exceptional strength and durability. These nanomaterials would be carefully engineered to integrate with the existing bone structure, providing reinforcement and resistance against physical hazards. Surgical alterations enabling humans to breathe underwater would require intricate procedures. Advanced tissue engineering techniques would be employed to create functional gill-like structures or implement advanced respiratory systems capable of extracting oxygen from water. The surgery would involve precise placement of specialized membranes and oxygen exchange mechanisms. Neurobiological modifications to enhance sensory abilities would involve a combination of gene editing techniques and neural enhancements. By modifying specific genes associated with sensory perception and integrating neural interfaces, humans could perceive and interpret intricate details of the forest environment with heightened senses. Augmented muscular strength and agility would be achieved through a combination of genetic enhancements and cybernetic implants.